Sixth grade math class 11. Linda's backyard is 20 feet long and 45 feet wide. She wants to space the posts equally along all sides of her backyard. What is the greatest distance apart that Linda can place the fence posts? Well, first we're going to draw the backyard. So we have a rectangle. It's 20 feet long and 45 feet wide. Now, I need to space these posts out so it's the same for 20 feet that it is for 45 feet. That means it has to be the same number that divides into both of those. Well, those are factors. The same number for both would be the greatest common factor. So the first thing I'm going to do is I'm going to find all the factors of 20. We'll make a t-shirt. We start with 1. 1 goes in 20 times. 2 will go in 10 times. 3 will not go into 20. 4 will go in 5 times. 5, if you notice 5 is already on the side, that's my sign to stop. So I draw my line. So my factors of 20 are 1, 2, 4, 5, 10, and 20. Now 45. 1, 45. 2, it will not go into 45. 3, 15. 4 will not. 5, 9. 6, no. 7, no. 8, no. 9, yes. But 9 is already on my list. So now I'm looking for the largest number in both lists. So I start with my largest number, 45. So 45, 15, 9, 5. So 5 is the first one that's in both lists, going from largest to smallest. So 5 feet is how far apart I'd want to space my posts. So it's the same for 20 as it is for 45. Write an expression equivalent to 14w minus 28. There's several different expressions that I could write. What I'm looking for is when I look at 14w minus 28, I'm looking for a number that will divide into both of those terms without a remainder. So the easiest number to go for right here is a 2. So I can, because they're both even. So I divide this one by 2 and divide this one by 2. In math, we call this factoring. So I'm factoring out of 2. 14w divided by 2 is 7w. That's where I put the number that I factored out. And 28 divided by 2 is 14. Now I could have also factored out a 14. That would have been the greatest common factor. So if I did that, 14w minus 28, divide both by 14. So 14 would go here. 14w divided by 14, well, that's 1w, so I can just write w. And 28 divided by 14 is 2, so minus 2. So 14 parentheses w minus 2. Could have also factored out a 7. As long as you factor something, that can go into both terms, or all the terms in the expression. Tell which given value, if any, is the solution of the equation. 12 and 200ths equals k minus 4 and 2200ths. And I'm checking if these are solutions. So the easiest way is just to solve for k. So they are subtracting 4 and 2200ths. So I'm going to add 4 and 2200ths. Remember, whatever I do to one side, I must do to the other. So as we're going to cancel, so I'm just going to write this over to the side, give myself some more space. 2 plus 2 is 4. 0 plus 2 is 2. 2 and 4 is 6. 1 and 0 is 1. So 16 and 2400ths. And that answer is right there. Zoe started a graph to show the inequality x is greater than or equal to 20. Finish labeling the number line and draw the graph. Well, I just place my number right in the middle. And I'm going to fill out the rest of the graph. And now x is greater than or equal to 20. So the first thing I do is I put a circle right at the 20. Now I have to determine, is it open or closed, which means 20 is a possible solution. So x is greater than or equal to 20. Well, is 20 greater than or equal to 20? It's equal to. So that means I'm closing my circle. I'm going to fill that in. Now I have to determine which direction the arrow is pointing. A thing to be careful of is a lot of people will just go by which direction inequality is pointing. You do have to be careful because that only works in certain situations. For example, when the variable by itself all the way on the left side there. So the easiest way to do it, to be certain, is the test point. So we're going to plug in 21. So we go 21, we substitute that in for the x, is greater than or equal to 20. So is that true? Is 21 greater than or equal to 20? That is true. So my arrow would point there. Now, if I chose the test point over here, like 19, is 19 greater than or equal to 20? And the answer to that is no. That's false. That's a false statement. So that tells me my arrow can't point that direction. A small gift box has a dimension shown. What is the volume of the gift box to the nearest cubic? So we have cubic because it's a volume. So the first thing I have to remember is volume is length times width times height. I like to use the cursive L because if I wrote it like this with the lowercase l, it kind of looks like a 1. So either use the cursive L or capitals just so you can tell the difference between the two. So now I'm just plugging numbers in. So volume equals 5 meters multiplied by 2/5 meters multiplied by 3.5 meters. Now, if you're confused on which one's the length, which one's the width, which one's the height, for a rectangular prism, as long as each number is used once, it really doesn't matter because remember that box can be turned. So now I'm just going to multiply 2 of these numbers at a time. So 5 multiplied by 2/5. So I put 5 over 1, because remember I have to turn that into a fraction, times 2/5. Now I'm going to use that cross canceling to make these numbers easier to work with, which means I look at diagonals, 1 and 2. There's nothing other than 1 that'll go into both of those, but 5 and 5 can both be divided by 5. So 5 divided by 5 is 1, 5 divided by 5 is 1. 1 multiplied by 2, and 1 multiplied by 1. So I have 2 over 1. So now I have 2 over 1 multiplied by 3/2. Well, I have to turn this into an improper because I can't leave it as a mixed number. So 2 over 1. Now how do I turn that into an improper? Well, I'm going to take those 3 wholes and cut them into halves. So 3, each of those cut into 2 pieces. That would give me 6 pieces. So sometimes you'll see a teacher put a multiplication sign there to remind you. So 2 multiplied by 3, that's 6 pieces, plus the 1 piece I already had. So that's 7 halves. Now, I'm going to use my cross canceling again, 1 and 7. There's nothing. Anytime you see a 1, you're not going to be able to do any cross canceling there. 2 and 2, I can divide both of those by 2. So 2 divided by 2 is 1, and 2 divided by 2 is 1. 1 multiplied by 7, 1 multiplied by 1. So I get 7. Now my units, well, if I go back to my units here, meters times meters times meters is cubic meters. Sometimes you'll see it written like this, and that's fine too. So either one of those is correct. Graph a polygon with vertices at 4, 2, 6, 5, 8, 2, 8, -4, and 4, -4. Then find its area. Well, remember, x is our horizontal. So this is our x-axis, and this is our y-axis. Here's our origin. We're right there. So as we move to the right, it's positive. Left is negative. Y, up is positive. Down is negative. So 4, 2, I go 1, 2, 3, 4. 1, 2. So over 4, up 2. 6, 5. 2, 3, 4, 5, 6. 4, 5. 8, 2. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2. 8, -4. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2. 2 down. Oh, sorry. 8, -4. My fault there. So we go 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. Had the 2 points kind of merged together there. And 4, -4. 1, 2, 3, 4. 1, 2, 3, 4. Okay. And it says, then find its area. So this is a polygon. So I'm just going to connect the dots here. So this is a 5-sided shape, or pentagon. Sixth graders do not know how to find the area of a pentagon, but if you look, if I draw a line connecting these 2 dots here, This breaks it into a rectangle and a triangle, which sixth graders do know how to find the area of. So first, the triangle. So the formula is 1/2 the base multiplied by the height. Now I'm just going to plug numbers in. So 1/2. The base and height must be perpendicular. That means they have to be 90 degrees. I think of it like the true height is like if I wanted to slide that triangle underneath the table, the base would be the part on the ground, and the height would be the maximum a table, the lowest the table could be, so I could slide it underneath there. So the base is 1, 2, 3, 4. We'll put parentheses around that. I like to do that for my multiplication. And then height is 1, 2, 3. So now I'm going to multiply. 1/2 of 4 is 2. Now I could set that up and multiply it out. I could do 4 over 1 and multiply it, but I know 1/2 of 4 is 2, and 2 multiplied by 3 is 6. And we're going to say 6 square units because I don't have any inches, feet. I have no units there. Now we need that rectangle. And if I look at that rectangle, that is base multiplied by 8. I go 1, 2, 3, 4. And 1, 2, 3, 4, 5, 6. And I know 4 multiplied by 6 is 24 square units. So the total is 24 plus 6, which is 30 square units. For every 5 muffins sold at a bakery, 8 donuts are sold. How many donuts are sold when the bakery sells 10 muffins? Complete the table, then plot the pairs of values on the coordinate plane. So I'm going to put my first set of coordinates in there, 5 muffins, 8 donuts. And now to generate other coordinates, I'm just going to simply keep multiplying by the same numbers. So I can either multiply or divide. But in the case of 5, it's just easier to multiply. So 5 multiplied by 2 would give me 10, and 8 multiplied by 2 would give me 16. Now I go back to my 5. 5 multiplied by 3 would give me 15. 8 multiplied by 3 would give me 24. I'm just choosing numbers. Really doesn't matter which numbers. You just need a couple of these to fit on my chart. 5 multiplied by 4 is 20. 8 multiplied by 4 is 32. And then we have muffins and donuts. So now I just need to choose an interval and graph these. Well, if I'm looking, I've got 5, 10, 15, 20 here. Oh, that would be perfect. I have 20, so I'm going to make these 5, 10, 15, and 20, which means each of these, and this is a 0, each of these is worth 1, my interval 1. And then donuts, I'm looking here. I don't want to go with that because I can only get to 20. So I'm going to count by 2s. 2, 4, 6, 8. This would be 10, 20, 30. I know I'm not going to be able to fit this last point on there, but I'll get 3 of them on there, and that'll be good. So now I just need to graph them. 5, and then 8, 2, 4, 6, 8. And then I go 10, 16, 10, 12, 14, 16. And then 15, 20. 15 and 20, 22, 24. I'm going to pause it. There's a class change right now. Okay. Now I just need to simply connect those dots. When you use, I have an angle ruler, but you could use any sharp edge that you want. And we'll put those there. As long as it touches all those dots. Okay. Now I need to look at these questions. For every 5 muffins sold at a bakery, 8 donuts are sold. How many donuts are sold when the bakery sells 10 muffins? Well, if I look here, 10 muffins, 16 donuts. So I just need to answer that question, 16 donuts. And then it says complete the table. I've completed the table. Then plot the pairs of values on the coordinate plane, and I plotted my 3 of my 4 points. I could, kind of extend the graph, but that's okay. Find the area of the trapezoid by decomposing the shape into rectangles and triangles. So this is a trapezoid. There is a trapezoid formula. You'll learn it later in school. But even if you forget the formula or until you learn it, you can always break this down into fundamental shapes, rectangles and triangles, which we do know the formulas. We've already used them. So first, we have a rectangle right here. So I'm going to do rectangle. And my rectangle is base times height. And it's 9 multiplied by 7. So 9 inches multiplied by 7 inches. Well, 9 multiplied by 7 is 63. And inches times inches is inches squared. Okay. Now I have my triangle. So triangle is 1/2 base times height. So 1/2 base is 3. Height is 7. Inches. Let me squeeze that in there. So one thing I have to be careful of is my two triangles in this one are the same. Those triangles do not have to be the same on every trapezoid. So if they're not, we got to do them separately, but I'll show you a trick we can do since they are the same. So we have 1/2 times 3. So 1/2 multiplied by 3/1 is going to give me 3/2. And I'm just going to leave that way now. So I need to multiply that by 7, which is 7/1. I look for my cross canceling, 3 and 1, nope. 2 and 7, nope. So I just have to multiply. 3 times 7, 21. 2 multiplied by 1 is 2. So 21/2. Now I'm going to go ahead and simplify this just because I want to add this to my rectangle. So I go 21/2 is 2 goes into 21. Let's see. I'll show you that here. 2 goes into 2 once. Bring my 1 down. 0. Bring a 0 down. 2 goes into 10 5 times. So 10 and 1/2. Or 10.5, whichever way you want to do it. So 10.5. Now, what I have to remember though is I have two triangles, so I can double this. Well, 10.5 times 2. Well, 2 tens is 20, and 2 halves is 1. So this is the same as 21. And now I go back to inches and inches, and that's inches squared. So I have 63 inches squared plus 21 inches squared. 3 and 1 is 4, 6 and 2 is 8, 84 inches squared is my final answer. So this was 6th grade Math Class 11. Thank you.